going to talk today about solid geometry. And the first thing we need to talk about are some terms or some definitions. And so these are our first terms. The first thing we're going to talk about is a prism. So a prism is going to have two bases that are the exact same shape, and they are going to be, a prism is formed by two parallel bases that are congruent. They have to be exactly the same shape and exactly the same size. And then those will be called your bases. So you'll notice here they've given us a triangular prism. We have a triangle on top and a triangle on bottom. Those are our bases. And then they are connected by faces that are going to be parallelograms. And frequently those are going to be rectangles, but they don't necessarily have to be. If you were to have a circle for your two bases instead of one of our if you were to have a circle for one of your bases instead of a polygon, we would call that a cylinder. And so a cylinder has two circular bases, and it is connected by one lateral face, and it's curved. So if you were to cut that apart, it's going to look like a rectangle, and it's wrapped around. That's going to be kind of like if you were to cut up a toilet paper roll. Next we have a pyramid, and a pyramid is going to have one base, and it's going to be a polygon. And then you're going to have triangular faces for every kind of pyramid, and those triangular faces will start at the base, and then they all meet up at the common vertex up at the top. A cone is very similar to a pyramid, but it has a circular base, and then again, because it's a circular base, you have a curved surface around the side, and then that meets up here at the common vertex also. So those are our new terms. So to give you some examples of differences in prisms and pyramids, I have some pictures. So our first one here is a triangular prism. Notice that for the triangular prism, we have a triangle on top and on bottom. So these are our bases. And remember, prisms are always named by their bases. So I have a triangle on top, and I have a triangle here on bottom, and that's how we know it's a triangular prism. If I only have one triangle, and it's on the bottom, and then everything else is a triangle, and those come up and they meet at a common point, or common vertex, that's going to be a pyramid. Same thing here. We have a rectangular prism, rectangular pyramid. Move on. A pentagonal prism and a pentagonal pyramid. So notice pentagon on top and on bottom. This one just has a pentagon at the base. And finally, a hexagonal prism and a hexagonal pyramid. So those are our terms. So we're going to look at an example, a couple of examples, and we want to classify each of these figures. So you want to tell, is it a prism or a pyramid, and what kind of prism or pyramid is it? And then you're going to name all the vertices, the edges, and the bases. So give you a moment to do that. And you can check your work here. For A is a cube. So A is a cube. B is a pentagonal pyramid. Next, we want to talk about what happens if you were to take your pyramid or your prism and you were to cut a cross section of it. So a cross section is going to be like you took a slice out of it, kind of like we slice up bread. And so we have a couple of examples here that we're going to look at. The first one is a cone. And if I was going to describe this cross section up at the top, I would say that this is a point. So I'm cutting a slice off just at the very top. So it's kind of like the end of an ice cream cone, and that's just going to be a point. if I were to move that cross section down, so it wasn't at the top, but it was farther down, every other cross section on a cone is going to be a circle. Okay? Or I should say every other cross section on a cone that's parallel to the base like this is going to be a circle. For this one, we have a pentagonal pyramid. And so if I cut a cross section here that's parallel to the base, you'll notice that that's also going to be a pentagon. And so if I move this cross section up and down, anywhere I cut it, as long as it's parallel to the base, that is going to be a pentagon. Okay. So I have a couple of other examples. And this one is using a block of cheese as our example. And so it says, a piece of cheese is a prism with equilateral. This one says, a piece of cheese is a prism with equilateral triangular bases. How can you slice the cheese to make each shape? Okay. And so the first one wants to know, how can I slice this block of cheese to make an equilateral triangle? And so we're going to look at this picture a little bit more carefully here. And so on this picture, you'll notice we've cut parallel to the bases, and we've created in here an equilateral triangle. So you'll notice this is the little cross section in here. That's our triangle. Next, we have the same block of cheese, just turned it a little bit differently. And they want to know, how can we cut it so that we make a rectangle? And so you'll notice, if we turn that block of cheese around a little bit, we can cut it this way and we would make a rectangle. So it's all about your perspective. So the first time, since it's a prism, we were cutting it parallel to the bases. This time our bases are here on top and on bottom, just like they were before, and we're cutting perpendicular to those bases, and that creates a rectangle. So be sure you're paying careful attention to whether you're cutting parallel to the bases or perpendicular to the bases. Next, we're going to talk about if you cut a shape apart, one of these 3D figures, we will create what's called a net. Okay, and a net is just a flat 2D shape that we could cut out and fold up to make a 3D figure. So we want to talk about which of these will make a cube. Because not all of these will make a cube, just some of them. So I want to give you a minute. I want you to think about how you could tell which of these will make a cube. First of all, we know that a cube has to have 6 faces. Okay? The faces are just the flat parts of the cube. Think of them as the sides, but the official geometric term is face. And so we count on each of these, and all of these have 6 faces, so we can't eliminate any for that. So we have to do some imagining in our minds about if I was going to fold these up, which of these would make a cube? And so I want you to think about that before you come back to class tomorrow. And we're actually going to do a hands-on activity so you can figure that out. So tomorrow you will get the answer in class to which of these will make a cube. One thing I will show you is this is our standard net for a cube. And this is just, if most people were going to sit down and sketch out, how can I make a cube, this is what they would draw. So you'll notice, if I fold this top and this bottom square up, okay, those become the front and the back of my cube. This piece that's in between those two is the bottom of my cube. I can fold up this left square that makes up the left side of my cube. And you'll notice I have 2 squares over here. So I'm going to fold those straight up. And this first square will make the right side of my cube. And then this very far right square will make the top of my cube. So that's kind of our standard cube net. And that's what most people think of for a cube net. But again, there's more than one option for that. Second of all, I want to give you a challenge problem here. And I want you to think about, if you were to fold this up, cut it out and fold it up, what shape would this make? You're absolutely right. That would make a cone. So again, if you don't believe me, tomorrow in class we're going to have some hands-on activities so that you can see that. Everything we've talked about today with all of our different shapes and figures is just kind of a start or an introduction to what we're going to be talking about in this whole chapter about solid geometry. And this is the part of geometry that I really enjoyed the most because we finally get to deal with some what people think of as real life shapes. So everything in life is not 2D the way we've been dealing with it so far, but is 3D, which is what we're finally getting into with these solid shapes. So I can't wait to see you tomorrow. Don't forget to complete the quiz at the end of the video.